Question 46. I'm looking back at my Mobius work. This is a Mobius strip with 3 flips. It's got one surface and one edge and 3 twists in it. I said once, I shouldn't say again. When you cut it down the middle, you get a loop of paper with 8 twists in it, an overhand knot, and 2 surfaces. A black surface, a white surface, a black edge, and a white edge. You can organize that into one of 2 types of solutions. There are the figure of 8 knots with 2 loops. It's a non-alternating figure of 8. Or there's the trefoil knot with 3 loops. There's a third group that I call a braid group. That's an example here. However, if you change that, you can see you can organize it into a coil. And then when you let it intersect itself, here's the braid right there. And that gets laid on a page, and then it gets drawn as a knot diagram. So this, as you can see, represents this. But you can't see the crossings because they're bunched up right there. They're all together. But you can see the crossings right here. That's it organized. You can see where the 2 cross the 3. That would have been the 6 crossings, and you can see those right here. This is the most special group because I found out that, well, I'm the first to do that. I'm the first person to let Mobius strips intersect as plane graphs, and I found a way to take them apart with what's called Whitney tricks. And there's 3 Whitney tricks that are needed. You can see this loop is pulled out here. There it is there. It's pulled out that way, and it's pulled across itself to get the unknot right there. The figure of 8s and the trefoils both make the unknots, and you can see the series of Whitney tricks to take apart that knot. However, one-flip Mobius strips have solutions like this, and there's always one Whitney trick. So we'll get rid of those. Here's the 3 flips. They all form the unknots in the bottom. That's the unknot, that little loop. Basically, when you pull the loop across itself, you got a picture that is invisible, and you cannot make sharp bends. That's just part of how to undo the double points in a smooth manifold. The Mobius strips are the figure 8s with 2 twists. They also form the unknots. However, the braid group, as you can see, here it is drawn without the crossings. Here's the first Whitney trick. Here's the second Whitney trick. Here's the third Whitney trick. And that has 4 loops left in it, but those 4 loops, if that was a plane, would represent 8 twists, because a loop in a ribbon cancels 2 twists. So there was 3 flips in the original Mobius strip, as you can see right here. There are 3 Whitney tricks to get the last, it's not the unknot, because that cannot be unknotted, to get the final solution. And there are 8 twists in the Mobius strip. When you cut it down the middle, these are in here. And you can see that the 8 twists are accounted for right here. Ooh, what's happened with my video? I pressed the wrong button, sorry. Oh, it's not rendering right. The 8 twists are accounted for with those 4 loops, because those 4 loops cancel 2 twists each. And I'm trying to understand that in algebraic topology, and it's really slow. Another example is this one right here. You can see the Whitney tricks. We end up right here. There's no coincidence, and I will figure this out. Confusing stuff. Very confusing.